Hello, my name's Dr. Mark Cobble. I'm an Associate Director at APEM. I'm going to talk today about the ORGIP Bench project, which stands for Benthic Habitat Changes Post-Construction of Offshore Wind. So the objective is to conduct multi-site analysis of benthic monitoring data to investigate benthic habitat changes post-construction of offshore wind farms. We conducted the work with Drs. Talicia Pillay and Lisa Skine of the National Oceanography Centre, and some review was also provided by Dr. Katrin van Landegem of Bangor University. And there were 5 main research questions, and this graphic here from the Eco-Change project indicates some of the things that we were considering. But the first one was, are there suitable metrics to detect changes in benthic habitats that could be applied to offshore wind assessments? Is there a measurable change, an increase-decrease in biodiversity and/or species composition? Are there localised and regional ecological effects around the infrastructure? Is there a change in ecological function as a result of biological changes, and can recovery and enhancement be demonstrated, and in what time frame? So we discussed approaches with the ORGIP steering group, and one of the main aspects was to collate information in terms of pre-construction and post-construction monitoring reports and associated data sets for offshore wind farms. So we looked at 47 sites, mainly around the UK, and looked for data that could be available through MEDIN, Marine Data Exchange, and also contacted developers directly. And of these 47, we got partial information, partial reports for the majority, but for 18 of them, we got all of the sets of reports and data sets we needed. We also supplemented this information with a literature review, which is particularly important for questions 3 to 5. And this project is ongoing, so there's going to be an interim workshop, and at that point there'll be a decision made as to whether we can use those data sets to conduct further analyses to investigate these questions further. And then there'll be a final report issued at the end. For this first question, we looked at the different metrics that were mentioned in the post-construction monitoring reports, and basically saw how frequently different ones were applied. So we've tabulated all the information for the various different offshore wind farms, but you can see for the figure here that commonly applied ones, as you'd expect, such as abundance, number of taxa, particle size analysis, invariably used across the different wind farms. But perhaps surprisingly here, non-native species were only actually mentioned in 7 sets of the 18 post-construction monitoring reports. So we think this is partly due to maybe the age of some of these wind farms and associated programs, so we'd expect that to be quite different going forward. And also as part of this, we've considered other metrics that possibly could be applied, such as AMBI maybe, or the Informal Trophic Index, to see what else, what other information we can get from the data sets. For the second question, we were looking at whether changes were reported in some of those metrics mentioned previously. Let's take abundance, for example. And perhaps not surprisingly, there's a lot of variation between the different wind farms in terms of what's reported. So for some there was an increase comparing pre to post-construction, and for some a decrease. But also post-construction, where there were multiple surveys undertaken, the direction of change wasn't always consistent. So there could be an increase from one year to the next, and then a decrease following this. So there was a lot of differences, but what was invariably the case is that where these changes did occur, they were attributed to natural variability, and this was mainly based on the patterns that were happening at the reference stations. So basically where there was a similarity between the two, but it wasn't always based on statistical analysis to determine those conclusions. There's obviously some definitive changes at the monopiles, where there's the foundations, where there's colonisation of the infrastructure. Now only 5 out of the 18 offshore wind farm monitoring programmes that we looked at did monitor colonisation of the foundations, but we think this is partly due to some of the reports being a number of years old, so we'd expect going forward monitoring programs are more likely to have this as part of the requirements. For the third question, looking at localised and regional effects around the infrastructure, this was mainly based around literature review. The monitoring reports did focus on more localised changes, so what was happening in and around the offshore wind farm site. But with a wider review, we're able to look at considerations for changes to physical habitat complexity, introduction of fouling communities, and potential presence of introduction of non-native species. And in terms of regional changes, there was very little in the monitoring reports about regional changes. So again, we focused on literature review, looking at changes to hydrodynamic regimes, sediment dynamics, considerations for electromagnetic fields and noise. There's not a lot of information out there about these aspects, but we're aware that the Eco-Wind project is looking at these, like accelerating the BOE programs, and there's going to be presentations on those a bit later in this session. For the fourth question, that's focusing in on ecological function. So again, conducting literature review, really focusing on these changes, physical habitat complexity, connectivity, changes in hydrodynamic regimes and sediment dynamics, and looking at the effects of those on the Benthic communities, but then focusing on what that meant in terms of ecological function and how that could change. There was no mention of ecological function in any of the monitoring reports that we examined, and there are large data gaps in relation to this, but the Eco-Wind Accelerate programme is looking to fill some of those gaps. So for the fifth question, looking at recovery and enhancement, we conducted literature review to see what was available in terms of these aspects. For enhancement, we considered reserve effects and co-location initiatives. And we did find there wasn't that much available in the literature at the moment. There's quite a few knowledge gaps. We did supplement this by looking at the post-construction monitoring reports as well. And for our definition of recovery for this question was actually where there'd been an adverse effect of an offshore wind farm, so recovery from that position. So the term recovery was used in 7 of the offshore wind farm reports, but in the context of returning back to pre-construction conditions, but not necessarily because there'd been an adverse effect of the wind farm. So returning back to the same sort of conditions that were reflected, for example, at the reference stations. So it's using the term in a different context to our intention for the question. So we're at the stage now where we've collated these data sets, and we're thinking about whether there's potential to investigate them further with maybe multi-site analysis, or applying new metrics, novel metrics, to get further information from the data that's been obtained. So thank you for your time. I'll be pleased to answer any questions.
Good afternoon, everyone. My name is John Spence. I'm from Exodus Group, and I'm presenting today on the ChemNID project, which covers nature-inclusive designs for offshore wind farms in Scotland. ChemNID stands for Collaboration for Environmental Mitigation and Nature-Inclusive Design. The project was set up by the Scottish Offshore Wind Energy Council, Barriers to Deployment Group, and was overseen by a steering group led by the Crown Estate Scotland. The key primary two key primary work streams off the back of this project were to develop appropriate mitigation measures, which culminated in a good practice library, and identify opportunities to apply nature-inclusive design, the latter of which, the NID part, is the focus of this presentation. The main aim of the NID work package was to identify ecologically promising and practically applicable NID measures, as well as provide evidence to support the consenting requirement for their development. The methodology that was adopted was to undertake a broad-scale NID literature review, followed by a SWOT analysis, a strengths, weaknesses, opportunities and threats analysis on the identified NID measures. Those outputs then were fed into a suitability review, which was undertaken for NID measures across Scottish offshore wind farms. The NID literature review revealed 5 different NID categories. The first category of which is reef-type structures and concrete blocks. These are blocks, modified, fabricated concrete structures, essentially, in various different shapes and sizes, providing substrata for the attachment of benthic species, as well as holes and crevices for shelter for fish and invertebrates. We also have modified mattresses, which is a slightly different category, deployed also on the seabed, quite similar to existing mattress designs, except they've been modified to increase the surface area and provide that habitat complexity. Other NID categories include adaptive rock protection, which is a bit like conventional rock protection, except that it has an additional adapted armour layer, which would increase the surface area and habitat complexity to encourage benthic fauna and flora to flourish, similar to the previous designs we looked at. There's fish hotels and cage type structures. So these fish hotel structures have holes in them and can be deployed independently, standalone on the seabed, or can be attached to infrastructure like these cages here, which are strapped or welded on to foundations. And then there's also water replenishment holes, which are essentially holes incorporated into the foundation designs that allow water to pass through, reduce scour, and create like cavities where fish and invertebrates can shelter. So as I mentioned earlier, we carried out a SWOT analysis, strengths, weaknesses, opportunities and threats, for each of the NID categories, each of the 5 NID categories that we identified. These included consideration of the suitability for fixed and floating offshore wind farms, the technical specifications and risks, the habitats and species that might be benefited, and any ecological evidence in support of these NID measures. We undertook this as a desk-based exercise initially, and then subsequently as part of a workshop with inputs from key stakeholders, including the steering group involved in the project, as well as the likes of the Scottish Fishermen's Federation and Scottish Whitefish Producers Association. So some of the key outputs from the SWOT analysis that apply to all of the NID categories are presented on this slide, and we can see that that the strengths are largely around the increased habitat complexity and the ability for most of those structures to act as kind of reef-like habitat, benefiting demersal fish and shellfish species, many of which are commercially valuable also. And there's also a strength around the spatial applicability of these designs, that they can be deployed in multiple different scenarios and different water depths. There's also opportunities as far as they go as for add-on structures. You can add on existing structures, and the applicability to fixed and floating developments. However, we have to recognise the key weaknesses. One of these is the data gaps. We have a limited understanding of how effective these are and how ecologically significant any deployment would be without empirical data. We also have limited suitability in soft sediments. Most of these NID designs are hard substrata, so that's a limit. We also have these threats. Decommissioning, if we remove the structures, that limits any ecological benefit, so that's a question there. We've also got degradation, if there's a release of contaminants or pollution over time, increased risk of non-native species, potential risk of fishing interactions such as exclusions and snagging risk, as well as additional financial risks for inclusion of such designs. So our suitability review took into account all of the outputs from the SWOT analysis, and also took into account the spatial allocation of ScotWind projects, and kind of did a little bit of a mapping exercise in relation to targeted ecological features, priority marine features and Annex 1 habitats, and such as on the map here on the right hand side, where we show the ScotWind projects and demersal fish species that could be targeted by NID. And we generally found that all NID categories have potential applicability across the ScotWind sites, although there are recognised some limitations there, but generally, broadly, they were widely geographically applicable, and with a number of ecological services provided by these measures. We have a selection process coming out the back of this, which it really takes into consideration the technical and environmental aspects, as well as taking on board the NID options that we've mentioned, starting with the design type of the type of wind farm, all the way through to selection of the NID measures. And this would be applied on a case-by-case basis. So in conclusion, we've identified ecologically promising and applicable NID options for offshore wind in Scotland. However, there is limited existing ecological evidence for the performance of these designs, especially in Scotland. Therefore, we propose that there should be some development of pilot projects in Scotland for NID, including monitoring of ecological performance. We recommend that NID can be considered at all stages of a project's life cycle, and we think there's a considerable opportunity for growth with regards to incorporation of NID at a plan and policy level. That brings us to the end of the presentation. The Kimnid report is available to download at the link below. Thank you very much for listening, and I look forward to any questions. Thank you.
Hello everyone, I'm Laurence Klippele. I'm based at the University of Glasgow, and as part of this pilot study we wanted to assess the use of passive acoustic monitoring as a tool for offshore wind farm benthic biodiversity assessments. So in the last 10 years, the Marine Directorate has been collecting passive acoustic monitoring data to understand how marine mammal populations are changing. But marine mammals such as whales are not the only ones that can make sound. Fish and invertebrates such as crustaceans, bivalves, and even polychaetes can all make sound. So we wanted to explore if we could use their sounds in this 10-year-long data set to potentially unlock data on benthic biodiversity. And to do this, we wanted first to see if we can actually detect any differences in acoustic biodiversity of different sedimentary habitats. And do differences in acoustic communities and indices actually relate to any differences in benthic biodiversity? So as part of this pilot study, we assessed data from 8 different locations from the east coast of Scotland from one day in April 2021. We then extracted data from different open access data platforms. We used modeled benthic richness data, habitat type data, environmental data extracted from EmodNet, and then we also looked at the number of fish that might use our areas as a nursery or spawning habitat. Then to find out if there's actually any soniferous or sound-making species in our areas, we extracted data from the National Biodiversity Network and compared it against the Global Library of Underwater Biological Sounds. Then in terms of the acoustic biodiversity analysis, we first used the manual approach, so where we manually annotated all of the different passive and active sound types using a software called Raven, from which we then calculated the phonic richness and also the abundance. And so this is a slightly more time-consuming task against a computational approach, which we also tested, where we calculated 7 different acoustic indices on both the raw data and on the data that was cleaned from any self-noise and noise pollution. So a total of 482 different species were found in the vicinity of our mooring locations, but only 49 of them were mentioned in the Global Library of Underwater Biological Sounds, which is actually not that surprising because the majority of our species were invertebrates, and these are famously understudied for their sound-making behavior. But as you can see here, different fish, crab, urchin, and bivalve species were actually listed as species that make either passive, so non-communicative sounds, and or active, so communicative sounds. Then when we looked at our acoustic biodiversity, we actually found a total of 16 different types of sounds. And as you can see here, the phonic richness, so the acoustic biodiversity is higher in habitat types that had hard and coarse substrates compared to those with sandy ones. So this indicates that phonic richness could be used as a proxy for changes in the habitat type. This is especially relevant for the installation of offshore wind farms, because we would expect the introduction of more hard substrate types in areas where previously you would have had less. Then in terms of our acoustic communities, we use the redundancy analysis approach to see what drives differences in our acoustic communities. And as you can see here, benthic richness, but also the number of species that might use the area for spawning and occurrence speed were important in driving differences in the communities. So this indicates that we can use these acoustic communities to track changes over time using, for example, trajectory analysis, but also that there is potential to use species-specific sounds to track changes over time. And although it's time consuming to do it manually, there are very fast developments in AI. So there's definitely a lot of potential of doing this more efficiently or even fully automatically in the future. Then in terms of the acoustic indices, we found a positive correlation between the benthic richness and the acoustic complexity index. And then with a higher benthic richness, we also found a lower unevenness index and quieter sounds. What I would say here is that it is a bit more complex and that we would need more data because it's not very intuitive to interpret. And it also seemed that although noise pollution didn't always have an impact on the values, sometimes it did. So they definitely would have to be used with care. But I would say that potentially the acoustic complexity index has potential to be used as an indicator for benthic richness, but ideally you'd always have some kind of ground truth data, so in the form of your acoustic community data. So to conclude, I would say yes, that we can use passive acoustic monitoring as a cost-effective and non-destructive way for long-term monitoring of benthic biodiversity. And we therefore have the potential to unlock 10 years of passive acoustic monitoring data, which could act as a baseline so we can understand not only past, but also future changes in benthic biodiversity because of the installation of offshore wind farms, but also, of course, in relation to climate change. And to conclude this talk, I also wanted to, of course, thank Ross Barnett, who was a research assistant on this project and was now doing a PhD in the University of Stirling, and Marta Bolgan for her expertise, but also, of course, the whole of the ScotMER team, marine mammal team, and everyone involved in collecting the data. Thank you very much.
Hello everyone, my name's Professor Liz Cottier-Cook and I work at the Scottish Association for Marine Science on the west coast of Scotland. We're working today, or I'm going to tell you today, about a project known as Invasive Non-Native Species Mitigation for Floating Offshore Wind. This is a project that started a couple of months ago now, so we're still in the early stages of it, but I would like to, or we've been invited to tell you a little bit about it. So here we go. So why are we interested in non-native or invasive non-native species, those that can cause significant harm to the environment, the economy, or to human health? Well, there are a number of reasons. Habitat modification, changes in ecosystem functioning, parasite transfer, yield reduction in fisheries and aquaculture, and also down to sort of blockages of cooling water in power stations. Just to give you an example here, this is a power station in the Mediterranean that had to be shut for a couple of weeks while it dealt with clearing 1 ton an hour of an invasive jellyfish. You can imagine the cost of shutting this power station, a considerably large power station of this particular country. You can imagine the cost of shutting this down, and you can see there the sheer volume of these jellyfish that invaded and were sucked into the cooling water system. So it's really important that we find ways to reduce the or minimize the introduction and then subsequent spread of these species. Now, why, floating offshore wind sector, it's very new. And how is this going to contribute, or can we minimise the risk of this industry in terms of introducing and then subsequent spread of invasive non-native species? So the project aims really to understand the key activities involved with this particular sector, identify the ones that are the most high risk for the introduction and subsequent spread of invasive non-native species, and understand what current management practices they have in place or thinking of using. Potentially looking at, well, we're going to be looking at other sort of sectors as well. So aquaculture, oil extraction, other maritime activities that use floating structures. So we're going to be using those as proxies. And then, of course, the ultimate aim is to provide recommendations to our funders, the Scottish Government, to ensure that this sector progresses in a considered and managed way when it comes to trying to minimise the introduction of invasive non-native species. So our key areas of interest really, because it's very much in its infancy, we're wanting to consider those activities and then possibly appropriate ways to mitigate for them leading to the introduction of invasive species. But looking at, they're going to be deploying really large floating platforms. They're going to be towing potentially for maintenance phase, towing these structures to a port or harbour, which we know are high risk hotspots in some cases for invasive species. Thinking about cable and anchor positioning, and then the decommissioning, all of these activities being potential routes by which invasive species can be introduced and then subsequently spread. And then obviously there's other activities that are common across the offshore energy and offshore maritime sectors, such as potentially bringing in large vessels from overseas, looking at moorings, laying moorings, offshore substations, cable burial protection, all of these things that are common across the maritime sector, many of the maritime sectors. So we're going to be taking a close look at all of these. So our key approach is then to review the environmental impact assessments and related documents that are already out there, and see what they include in terms of what non-native species or invasive non-native species are considered, and what management practices and mitigation measures they've identified in those assessments. Then to engage with key stakeholders, discussing their activities and approaches to managing these invasive species, and then, as I say, collating best practice and recommendations for our funders. So the stakeholder engagement, the first phase in terms of just mapping and figuring out which are the key stakeholders, that's now taken place, and we're contacting those stakeholders now to arrange one-to-one interviews, basically to have an in-depth discussion about what methods they currently use to minimise and deal with invasive species if they do find them on any of their structures, and also to get an idea of what barriers they're finding in terms of how to effectively manage these species. Also, we can discuss with them about, or hoping to discuss with them, any additional management measures that they think of that could be beneficial to use in the future. So for the future, then, we're looking at, as I say, taking the consultation with stakeholders, doing these interviews within the next month to 6 weeks, looking at using this as an opportunity to discuss various options with them, and looking at, just best practice really that we could bring into this new sort of sector. Understanding what, if any, monitoring is already taking place with projects that are already underway, and just gaining a much stronger understanding of the sector and how it is specifically dealing with the problem or the risk of introducing non-native species. So, as I said, we'll report all of these findings later on this year to the funders. So thank you all so much for listening. Just take this opportunity to thank our funders, Scottish Government, our advisory board members and everyone to date who has assisted with this work. And if you would like to be involved in this as a stakeholder and we haven't contacted you already, then please do get in touch with me. We'd really love to speak to you and hear your views on how best this sector can move forward in terms of minimising the risk of introducing invasive non-native species. Thank you all very much.